Welcome to this video on Cisco ACI and integration with different networking solutions. We'll speak about integration with VMware, vSwitch, and Linux containers. Here you can see the main screen of the APIC, the Application Policy Infrastructure Controller. We have here defined an application which is made out of 3 server groups, actually 2 server groups and 1 external endpoint group. That's what EPG stands for clients. You can define in ACI the relationships between these endpoint groups or server groups. So clients are allowed to speak to web servers, and web servers are allowed to speak to databases. Clients are not allowed to speak directly to databases. We have a bunch of VMs in VMware vSphere that we would like to assign to these different endpoint groups. We have already assigned the client and the database, but the web servers are not yet in the corresponding endpoint group. So let's see how to bring them there. We can go to the database, and from the database we should be able to ping the web servers. Of course, not yet, because again, the web servers are not yet in the corresponding web server group. So that's why the ping is not working from the database. Let's see how to do that. The easiest way is through the integration between ACI and vSphere. This is done through the use of the distributed virtual switch in vSphere. As you can see, there are a number of port profiles. There's a vSwitch, actually a distributed virtual switch that ACI created. In ACI, we can see as well some information about the VMware cluster, such as the ESX hosts inside of the cluster, the physical NICs of those hosts, the virtual machines running there, whether those virtual machines are already associated with the distributed virtual switch that ACI created or not, which is the case with this one. And we can see as well some details about the distributed virtual switch itself, like for example the different port groups that have been created by ACI. Right, so the only thing we need to do is to tell ACI that the virtual machines for that web server group are to be found in this specific VMware cluster. This is easily enough done. We go to the web server group and we just define as virtual domain the corresponding virtual center cluster. This is what we are doing now. And immediately after having done that, we can go to the center and we will see that a new port group exists now in the VDS. So now the only thing left is assigning the virtual machine to that port group. Notice we haven't spoken about VLANs or anything else. This is all everything done in the background. So after doing this, now the database is able to reach its first web server. Alright, let's go for the second one. In this case, we will not use the distributed virtual switch, but the virtual standalone switch in VMware. Why? A lot of organizations still have this switch because it's cheaper. You don't need the Enterprise Plus license. And we will do this with the second virtual machine in this cluster. So in order to do this, we will have to do some manual work. So in the previous case, ACI did everything for us. Now we have to create a port group, as we can see here in the picture. In the virtual switch, it's called myapp-web, and we associate it to a specific VLAN. In this case, VLAN 181. We have to do the mapping manually, so we have to tell ACI that this VLAN 181 corresponds to the web server group, which is what we are seeing in this screen. Packets coming out of this port on VLAN 181 belong to the web server group. So once we have this definition done, we can go to the virtual machine and associate it to that port group in the standalone virtual switch. This is what we are doing now, and magically the database can already ping its second server with the IP address .102. Now let's do something a bit more interesting. We will add a third web server with the IP address 131 And this web server will not be a virtual machine in VMware, but it will be a Linux container. So let's start ping. It's not working as usual because the container is not there just yet. We go to a Linux machine with Docker. We are using Docker here installed, and if I manage to enter the right password, we will see that there are no containers running. We will have to use some custom networking because standard Docker networking doesn't expose containers to the external world. And for this, we will use Open vSwitch. We could use the standard Linux bridge, but I found some problems with ARPs. We are using here standard an Open vSwitch connected to a VLAN 181, which is the same VLAN that we told ACI that web servers would be in. Right, so once having done this, now we can launch the the Linux container. I have a script here that will do that. All parameters are predefined in the script. The only thing you need to do is give in the 4th octet, and you can see in the background here in the database window that the 3rd web server is now reachable under this IP address 131. So in the later section of the video we will go above the details, but here we can already see that there's a new interface associated with the Open vSwitch bridge in VLAN 181, which is Virtual Ethernet 131. This Virtual Ethernet interface is on one side connected to VLAN 181, as we are seeing here, and on the other it's connected to the container that we just created. Docker, per definition, doesn't expose, as I mentioned, the network attributes of containers, but it's something like the DSL router at home, right? So containers are created behind, and from a network perspective, they are invisible. At least from an IP perspective, they are invisible to the outer world. You can expose some ports, but ping and such things don't work. Now we can go back to our web server group in ACI, and we can see whether there's any endpoints associated with any server, and we can see all three endpoints: the virtual machine associated on the VDS, the virtual machine associated on the standalone switch, and the Linux container. Obviously, there's more information for the VDS machine because ACI can read those information details over the virtual switch. The other two cases, the standalone switch and the Linux container, there are not a lot of details. It's basically like a normal switch learning MAC addresses. Alright, let's have a look into how we implemented the network for this container. So here's where we stood before. We had a look at the bridge on VLAN 181. On the upper right side of the screen, you can see an image with the network design for this container. Here you can see the container is running. Please apologize the 7-hour time difference, but I happened to record the first time of the video yesterday evening. I have slept a couple of hours and now I'm recording this part. Right, I used this script to launch the container. Let's have a look inside and see what's there. So some basic introduction with some information in case not the right parameters are entered, some variables, and now the container is created using a new Ubuntu image. The --net equals known parameters is pretty interesting. It's very important. It tells Docker not to create any network infrastructure for this container, which it would do unless this parameter is done. And after having the container running without any network, we will add the network manually. We will add the container to the Linux bridge using Open vSwitch. I have tested the standard Linux bridge. I found Open vSwitch runs a bit more stable, a bit more reliable, and more importantly, I found some ARP issues with the Linux standard bridge, and this is why I'm using Open vSwitch instead. I'm just using Open vSwitch as a plain layer 2 bridge. I'm not using any advanced functionality here from Open vSwitch like network overlays or that kind of stuff. So let's have a look at this script that creates the network infrastructure for the container. Again, some basic stuff about the parameters, about calculating some variables, and let me scroll down so that you can see the main body of the script. There you go, it's not that long as you can see. This is the last part, so let's go up to this first important line after retrieving the PID. From the Linux container, we create a new network namespace associated to that PID, to that process ID. So you can think of this as a VRF, as a virtual network space inside of the Linux server, which will be running inside of the container. The second thing we do is we create a couple of interfaces. This variable IFNO, if number, interface number, is 103. So we create a virtual Ethernet interface 103 and a virtual Ethernet interface 10,103. Both interfaces, as you can see on the picture, on the top right side of the image, are short-circuited with a pipe. So what you put on one side comes out of the other. And we add the VETH103 side of the pipe to the bridge on VLAN 181 using the appropriate command for Open vSwitch. We bring the interface up, VETH103, and we are done on this side of the pipe. Now we have to work on the other side of the pipe, the VETH 10,103, which is associated in the container. We have to change its name to ETH0 so that Ubuntu is not surprised there. We bring it up, we give it an IP address, default gateway, and in the last line of the script, I generate some traffic from inside the container in order to update all CAM tables and the switches involved in this example. So this is basically it. In this video, we saw how ACI can integrate with vSphere's distributed virtual switch, with vSphere's standalone virtual switch, and with Linux containers using a custom Open vSwitch layer. Thanks for watching.